Hello, my name is Natalie Lamb and I'm really excited to deliver my presentation to you today all about the work that I've been doing with SENTRY on energy optimization in wastewater treatment. Okay, so why am I talking about this today? As we all know, climate change is an unprecedented challenge on a global scale. The UK water industry is responsible for providing 15 billion litres of water and treating sewage from over 28 million properties every single day. But doing so is a really energy intensive process. The water industry is actually the fourth biggest emitter of greenhouse gases in the entire country. And we're emitting over 5 million tonnes of CO2. Yet the water industry intends to be part of the solution to this climate crisis. So that's why in 2019, water companies in England made the ambitious pledge to get to net zero operational emissions by the year 2030. This is actually 20 years ahead of the government's commitment for the country as a whole. My research is all about trying to make us take the first step in this massive roadmap towards energy optimization and net zero emissions. So let's get started. So normally I ask people when I'm presenting, what do you think this is? But I'm going to sort of whiz through that a little bit today because it is a video presentation that I'm delivering today. So whatever this thing is, if you're sitting at home and watching this video, it's found in all sorts of different environments. So it's found in teeth in the environment, so in rivers, in your tap water, and in sewage treatment works also. So actual answer to this is a biofilm taken under an SEM microscope by the University of Sheffield. So biofilm is actually what makes you need to brush your teeth in the morning, because biofilm sort of grows overnight. Even though you brush your teeth at night time, there are still microorganisms that are present and alive, and they form this biofilm. But it's also present in lots of other environments, and one of those is wastewater, which is what we're talking about today. So biofilms are like a sticky spider's web of all the building blocks needed to live. It consists of microorganisms and lots of other things all stuck to different surfaces, like the inside of pipes or the inside of tanks in wastewater treatment plants. So anyone who's worked in instrumentation in wastewater knows that when you put a device in wastewater, a horrible gunk sort of builds on the device or indeed on the surface of the tank, and this gunk is actually biofilm. The probes that I'm talking with you today that I've done some trial work with, called SENTRY probes, are actually designed for this gunk to form on it. So when that happens, it's actually a good thing. It doesn't need cleaning, and that's kind of how it works, is the gunk forms on it and it uses that biofilm, it uses that gunk. How is it actually working? So similar to a microbial fuel cell, actually, in its design, what it's doing is normally microorganisms, when they reproduce, they produce electrons when they respire, which is sort of lost to the environment. What this device is doing is capturing those electrons to give a quantification of the activity levels of microorganisms. So essentially, it's a little bit like a Fitbit, but for the biology of different water environments. And you can put it in any water environment and it tells you what the activity levels are like of the microorganisms within it. So when I was explaining earlier about that biofilm growth on the surface of the probe, that's a good thing. So that means it's able to quantify the activity levels of the biofilm that's growing on it. So I'm here today to talk to you about this energy optimization piece of work I've been doing at the moment. So this driver to net zero is something revolutionary. We're really having to rethink our current practices to achieve that. So what I'm doing in this work is a little bit like a light switch. When the microbial loading is low coming into a works, parts of the plant in a sewage treatment works can be turned off to save energy, just switching lights off in your house when you're not using them. So basically, it's found that aeration in a sewage works is a really massive energy sink. It consumes about 67.2% of the total energy use of a water utility. So that's why I'm really focusing in on aeration. So aeration is used in different water treatment works, sewage treatment works, to keep the microorganisms alive who are digesting the sewage, because many of them need aeration, oxygen, to respire. So we're talking about when the levels are low of the microorganisms in the works or in that particular part of the plant, we can turn off that oxygen. They don't need as much of it if there's not as many of them. So this particular case that I'm talking with you about today, they have one sensor before the bath, one sensor after the bath, and all of the sensors are connected by wires to a control panel on site. And this is the picture of the probe itself in the case study Wastewater Works, and you can see there, maybe if you've got good eyes, a little bit of formation there. That is the biofilm that's sort of grown on that probe over time. The first thing I was looking at was the case study site over aerating, because if it was functioning fine, if the optimum amounts of aeration were being provided, then there was no need to do any further work on the site. And we did find periods of time where the microbial load was really low to the BAF unit, and yet the DO, the dissolved oxygen on the site, was high. So there were incidences there of over aeration, so proof that we could maybe optimize that aeration a little bit better. And then the next thing that I was sort of looking into is, when did the case study site have the lowest periods of organic loading? So the idea behind this is, okay, so the plant is over aerating. When are some of those times that we could stop that aeration? When are the best times of day, the best day of the week, that we could do that? So we're looking at the trending organic loading on the different days at the different times and so on, to work out when was good, when was bad. So for instance, Sunday has got some really low levels, whereas Wednesday here has got some really high levels. So what am I actually able to do with all of this really exciting data that I've been collecting? We've shown that the case study site is overrating. We've shown when the lowest periods of organic loading are. So when are the best times to turn off these blowers and stop this over-aeration? So we've been, so I've shown you this slide already, but the next bit is really exciting. So it's not all about sort of long-term challenges and climate change and net zero and all these things that sort of very blue skies thinking. This sort of work is also really important for the people on the ground, for the operators, for the people managing the plants, because not just is it helpful towards climate change, but the case study site that I've been working at, by turning one of the 5 units off, the BAF units off, there's an energy saving of 10 to 20%, which equates to £50,000 to £100,000 per annum. So for someone operating that particular case study site, this is a massive saving. And this is without sort of the plant collapsing or any sort of negative occurrences happening because of this work. So we're not just optimizing here for blue skies, bigger picture, but we're also doing it for everyday sort of health, really. This isn't a groundbreaking project that I am, as an individual, working on. It's just that next little step towards net zero. But it's with all these little steps that we're going to make some really big changes. So overall, I've been trying to make little steps towards energy efficiency to try and get to that net zero sort of massive goal in the future. And how I've been doing that is really working with wastewater and water utilities to try and think proactively rather than reactively. You know, we've got this new parameter, this new measurement, microbial activity. Sometimes they're not entirely sure what to do with it. But we're trying to use it with them to work on goals such as energy optimization, to make it mean something for them. This is a different way of working than what they're used to sometimes for some of the companies. So we take one reading a minute and it's transmitted every 15 minutes over sort of Wi-Fi or over just a normal SIM card like what you have on your phone. I think one real big plus for operators is that it's no maintenance, so they don't have to go in, they don't have to clean it. We've got one that's been at United Utilities now, and it's been in place for several, like 3 years without any cleaning or anything. Because when that biology is growing on it, that's how it works. So unlike some other sensors, it can be really reliable. So I think in future, one thing I'd really like to do is expand this work and find some more companies who want to give this a go and are willing to sort of try and turn off their aeration or turn it off at certain points. I think that'll be really exciting to try and help other companies do this. So I've been Natalie Lamb talking to you today, but you might have seen some of my colleagues around, and these are some of the people that I'm working with on this exciting project. So thank you very much for both of you for having me here today, speaking on your behalf about some of the exciting work we're doing. And yes, thank you very much for listening to me. I've been talking all about SENTRY and energy optimization. Feel free to get in touch with me, leave a comment, leave a thought, leave a question, or just come say hi and have a cup of tea. I'm quite friendly, really. Thanks very much for watching my presentation today. Thank you. Bye.